Welcome everybody to our April Small Firm Forum, where we'd like to provide education, but also a great atmosphere for small firm architects. And we have larger firm architects online, obviously, and sole proprietors, and a wide range that AIA East Bay has to offer in terms of membership. So thank you all for being here. We have a really cool educational program here today having to do with waterproofing, and AIA East Bay is proud to host AVELAR, a premier engineering and architectural firm that specializes in waterproofing and the potential risk for design professionals. And Matthew, Kirk-Cortez, long-term friend of mine, went to college together, but also has been an active member here at the AIA East Bay for over 10 years. And we met through the Young Architects Forum and continued to grow our relationship that we had started at Cal Poly, and he is a licensed architect and a member of AVELAR now. And AVELAR, as an architectural engineering firm with nearly 50 years of experience, has built a reputation for excellence in the forensic investigations, architectural design, and construction defect analysis. So they cover everything. When you have a problem in the building, they are the experts to go to, and from soup to nuts. So when it comes to design, details, construction, lawyers, and all the way through. So if anybody has any waterproofing issues, that's the premier firm to go to in terms of where they are. They're located here in Walnut Creek in the East Bay, so part of our jurisdiction. And like I said, they just have a build team for any portion of that of the project that you're in that potentially needs some help or expertise when it comes to waterproofing and building enclosure design. So Matt and Kirsten, you're going to be presenting too as well?
No, Kristen Anderson. I'm just introducing a little bit of information about AVELAR.
Okay, so kind of doing what I'm doing. All right, sorry, we're going to overlap a little bit then. Yeah. I wasn't sure, we didn't really collaborate on this, but it doesn't matter. We're talking about the same thing here. And yeah, Matt's the go-to guy here. He's got an extensive experience in modern construction and challenges of waterproofing. I'll hand it off to you, and probably, hopefully, we'll hear some of the same content. All right.
Okay, great.
Thanks.
Thank you so much. Yeah, number one, we're just happy to be here, and thank you very much for inviting the topic of waterproofing to the East Bay AIA. I think it's a good one. We're looking forward also to the October symposium, waterproofing, and gearing up for that as well. My name is Kristen Anderson. I'm a senior architect with AVELAR, and I'm just going to provide a few introductory comments about AVELAR and a breakdown of what Matt is going to be presenting. First off, though, a little bit of additional information about Matt. He's an architect. He also has earned a credential as a registered roof observer from the International Institute of Building Enclosure, and is a California Certified Access Specialist. Matt has years of experience in building enclosure design and waterproofing. Overall, Matt is focused on creative, collaborative responses to the realities of project requirements. He understands the impact that comes with each design decision. Before he begins, here's a brief background on AVELAR and an introduction to the presentation. As Tim was mentioning, AVELAR is an architectural engineering firm with nearly 50 years of expertise. The firm has built a reputation for excellence in building enclosure waterproofing design, interior environmental analysis, and litigation support. Our home office is in Walnut Creek. We provide services throughout the Bay Area, the West Coast, and globally. AVELAR's team includes 28 licensed architects, structural engineers, and general contractors. We bring this unique expertise to architects both in the design of new and retrofit projects and the analysis of projects in distress. The firm has 3 divisions: forensic and litigation support, interior environmental analysis, and reconstruction design. During this presentation, Matt will draw on AVELAR's extensive experience to explore the challenges of waterproofing in modern construction. He will break down the types of technical assistance a building envelope consultant can bring to an architect's design team. By using a building envelope consultant, architects can increase the performance and durability of their designs. By increasing the building envelope performance, architects can reduce risk to the design team, the contractors, and the project owner. We can take questions during Matt's talk, also at the end, and we will post a code to a survey. Would appreciate your input and feedback following. So now let's give a warm East Bay welcome to Matt Cortez.
Thank you guys, appreciate it. Okay, who's ready to talk some waterproofing? Thank you guys all for joining us. What we want to go over in this presentation is, I'll try to be as brief as I can so we can leave some room for questions at the end. But we want to talk about understanding what risks we have as architects as it relates to building enclosure design. And the sort of challenges we see in new construction and reconstruction, as well as identifying common issues of poor enclosure design and strategies for mitigating the risks that we see. So as an architect, the number one thing that's going to be the start of all this stuff is building system failures. Once the building fails and we have some water intrusion issues, then you start to get questions about, did we follow the standard of care? Beyond that, there can be some litigation action and insurance risk or insurance implications as well. So these are the things we want to generally avoid as architects. So let's talk failures. There can be things like isolated failures where you have a particular detail wasn't executed correctly, or there are things like systemic failures where we see massive building-wide failures, rotting of sheathing, leaking, uncontrolled water leakage, things like that. And that's usually the start of, did the architect follow the standard of care as your drawings get scrutinized? So we all know what the standard of care is. The architect shall perform its services consistent with the professional skill and care ordinarily provided by architects practicing in the same or similar locality and same or similar circumstances. Sorry, that's a little fast right there. But basically, are we following what would be done by our peers in similar conditions, and are we qualified to do that particular type of work? Similarly, from the AIA Code of Ethics and Professional Conduct, in practicing architecture, members shall demonstrate a consistent pattern of reasonable care and competence and shall apply the technical knowledge and skill which is ordinarily applied by architects of good standing practicing in the same locality. So that's that sort of consistent pattern, right? Is it an isolated incident, or is this more of a track record of not being, not following the reasonable care? When we talk about litigation risks, first thing is client and project evaluation. Who are we working with? Are the people that we're working with, are they developers that intend to sell? Are they developers that intend to hold? Are they homeowners? Each of those sort of client profiles provides a different risk profile as you kind of go through your pre-project checklist, right? Homeowners, typically you can reason with pretty easily and come up with solutions. Developers don't really care. Their bottom line is the dollar, right? So we gotta kind of figure that risk into the sort of projects we take on. Do you have experience with the project type? Condo projects remain one of the most high-risk things you can do as an architect, but there are even risks in single-family residences. Things that, like, for example, areas in high water tables. Things that we don't necessarily think of as being out of the ordinary for a small firm owner, like a single-family residence here in Berkeley, but there are other challenges that you can face. For example, retaining walls with perched water, things that we're not necessarily familiar with, and from a technical standpoint, can get us into some pretty big trouble. I'm sorry about that. And then, so do we have experience with specific project conditions? That's similarly like climate considerations. Where is the water table generally? Are we in a spot where we need to, which way, for example, here in Berkeley, fog is gonna come in every day, right up Alcatraz Ave and smack your building right in the face right there, right? So those are, and then is there gonna be drying that happens right there? What's this overall climate cycle about how we can absorb and get rid of moisture? Like as I talked about previously, after the sort of litigative actions have gone through, insurance carriers can start to see with a more watchful eye, are you a more high of a risk as an architect to insure? Per the Civil Engineering Online article, California, as with most things, remains one of the states with the highest number of claims. And this is not likely to go away anytime soon. You can probably bet on our insurance premiums increasing no matter what, especially if there's any sort of litigation or failure happening there. New construction and reconstruction is hard. There's a lot of different things we need to consider when all these things are coming together in a building. There's constantly updated code requirements. We have a lot of different control layer requirements within exterior assemblies. So it's not just, your basic stone building, right? We have your structure, we have your vapor control, we have your water control, we have air control. All of these things can contribute to a successful project from a waterproofing standpoint and building enclosure standpoint. Lots of CA services, this is kind of a big one. For lots of small firms, owners don't particularly, they tend to phase out construction administration processes, services for architects. And that can become challenging because then we leave a lot of design intent decisions up to architects and owners who aren't necessarily aware of all the things that we were thinking of as architects. There's a lot of new markets, as the people from Ram Independent here can attest. There's a lot of new markets and materials coming into the products and materials coming into the market. There's not a lot. There can be areas where installer experience is low compared to the product. Fluctuating market conditions. We'll get into this a little bit more too, but basically, we've seen in the last couple of days, our markets can vary wildly, right? I mean, we've also seen in the past few years that material availability can vary widely. So sometimes we need to make some adjustments during construction to substitute particular materials that we had planned on having there from the very beginning. And when it comes to reconstruction, it's always higher cost to repair something that's been done than to build it as new, generally because you need to talk about selective demolition. We'll talk about just really more intricate and skilled work, not to mention if there's somebody that's living in these particular areas where we're fixing, you may need to relocate them. So let's talk about code requirements. These is, like we all know, they're getting updated every 3 years, and they aren't getting less stringent, especially when it comes to energy efficiency and air exchange requirements. This is one of the big drivers in the industry about having a really tight building envelope. The energy requirements of your buildings are getting higher, and so that means we need to have less air exchanges per hour, which means we have to have a more tight building enclosure. So that means that as opposed to, construction methodologies that we would have seen in the early 1900s, where we, the quote unquote loose construction, where things got wet, they dried, got wet, they dried. Now if they get wet, there's not enough air or airflow to dry them. So then we run into rot relatively early in the lifespan of a building and decay if we do have a weatherproofing breach. There's additional assembly requirements. For example, Chapter 25 of the CBC and CRC, we now are required to provide a drainage plan in our cement plaster assemblies. This is something that's relatively new in the code cycle. We may not have the experience about how we detail these things as we're now required to by the building code. Yes?
Is that in all climate zones, or is that in certain?
It's in specific climate zones. I think it's mostly 3A, B, and C. Yeah, the code has what your requirements are based on climate zone that you're in. And I believe it's like 3A and C require a 95% drainage layer or something like that, and 3B does not necessarily. I forget exactly what it is, but depending on where you're, even in the East Bay, I think Solano County can be different from San Jose or Santa Clara County in terms of climate zone that you're designing to. So those are things we'll need to consider as we talk about where our project is and how we implement them. This is specific for cement plaster, but there will be other different things. Yes?
Is it new or?
It depends on the generally new, sometimes reconstruction depending on the extent of the reclad. If it's the whole building, you will be required to do that by the building official. If you're patching, most likely not, because then your planes will be off in terms of your assemblies. Control layers. So our walls are not just walls anymore. They're ways to control bulk water. These are your general claddings, cement plaster, metal panel, fiber cement shingles, cedar shingles, the bulk water. That's just one control layer. Air and vapor control. These are our weather barriers. This is kind of a newer one on the market, a liquid applied. Sometimes these materials do both things, like air and vapor. Sometimes they do one, sometimes they do none. Thermal control areas, we're seeing a lot more stringent insulation requirements, especially on the exterior of buildings. So that's another just layer of the building envelope that we need to consider when we're designing. Loss of CA. Owners don't particularly, their buildings are already expensive. Owners are hesitant to spend more money when they feel that they can cut. I would argue that, you know, having an architect or an enclosure consultant on the job during construction will save you tons of headaches and time to rebuild something if we do it right the first time. Lack of perceived value is what I'm talking about, the penny today versus the dollar tomorrow. So that means we have less opportunity to provide our design intent to contractors on site while decisions are made, and we just leave it to the contractor and the owner to interpret what we intended with our drawings rather than being able to express and give direction. And furthermore, there's no opportunity to reject work. If we see something is not conforming with the construction documents, we don't have an ability to reject it if we're not on the job site. So this is an example of a recently opened building that we looked at. This is a deck parapet. We have a roof that was installed outboard of an old roof that came down. So there's lots of different reverse lapping happening here. There's some spray foam that was injected for some reason. Anyhow, this doesn't look anything like what the architect drew as the detail happening here. So if we're not there during construction administration, we don't get to provide that input in terms of rejecting work. Yeah.
That's such an interesting topic because it happens a lot.
Yeah.
Especially depending on the scale of the project.
Correct.
You know, if you're a residential, let's say a small residential architect, a lot of times contractually it's, hey, I can help you out hourly if you need me. And that conversation, like you said, just usually goes away. You know, you never get the call, or you only get the call when things are a problem and it's your fault.
It's like, it usually comes 6 or 8 months later when there's an emergency.
So is it that, you know, as architects, I assume it's better to have those conversations early on in the process and maybe even put it in as part of the contract to say, hey, look, I'll be here and I'm available, and you know, there's a small fee associated with that, but here are the value points, like you said, that for the reasons I should be here on site, or I should be available to you as an owner's representative to the contractor.
Correct, yeah, and with all these things, earlier the better. If you get it on your owner's radar from the very beginning that this is going to be a long, expensive process, and we need to do everything we can to help them protect their investment as well, right? This is not about our own professional liability, even though it is. But we want to have successful projects. We want owners to have successful projects. And one way to do that is to make sure that we fulfill all of the obligations that we have as architects.
I have a question though on that line, which is if you had to give a ballpark approximation cost, how much does it cost for the actual construction administration versus the design? Is it like plus 20%, plus 50%, same cost? Is it, you know, that's hard to answer. But.
Sure, I mean, it depends on the scope and scale of the project. So for example, at AVELAR, when we design a reconstruction sort of project, our CA fees are generally about the same as our design fees. That's because we are very, very involved in the reconstruction. We're there once a week at a minimum, right? Depending on the scope and scale of a residential architect's project, let's say, you know, you probably want to be there at the big ones, right? First installations of a window, first installations of a door, first, you know, transitions between any below grade spaces and above grade spaces. Initial installs are really good to be that at a bare minimum. Sometimes what I'll do with some of the projects is develop a checklist and hand this to the contractor about this is what I want to see at a bare minimum at the beginning of the project based on when or what the scope of the project is, how many different systems we have, stuff like that. So to answer your question, Chad, it can vary. It can be relative, you know, if you're doing an addition, it's not a lot, you know, maybe checking out a window install and you tie into any existing weather barriers. New construction, you can have a lot of different systems that kind of come into play there.
I have a follow-up question. This is just a topic that always comes up. So, are there other ways and means to provide CA without the traditional "I'll be on site" kind of approach, so that maybe it isn't as much time and money that the homeowner has to pay for you to drive there and spend time on site? Are there other ways that you've seen have been successful with contractors communicating to the architect to help with contract administrative services through, I don't know, webcams or videos or daily logs or something like that? Does that
Yeah,
help?
I mean, a lot of times the most successful projects I'm a part of is when a contractor really gets into the drawings before we start, and they just have a list of questions before we even break ground.
Pre-construction?
Yeah, definitely. Those are always generally successful because the contractor wants to work with you to iron these things out that they know they'll run into 5, 6, 7 months down the road, but they want to get everything lined up so their sequencing doesn't get thrown off. In terms of new technologies, yeah.
I thought we can't reject work, we can only tell the owner it doesn't meet the design.
I mean, technically that's correct, yes. We would follow what the AIA B201 calls for.
As a manufacturer's rep too, it's really important for us to be able to stand behind the systems that are being, specified on the project. So, a lot of times we want multiple systems, that have continuity and waterproofing with a certified applicator, installing our systems as well. So we require pre-cons oftentimes, pre-construction job meetings, there's checklists that need to be, looked at. What's the lagging conditions? What's the backfill? What's, we're talking about below grade, but, with a lot of what AVELAR does as well on the restoration side, it's that last photo of the roof. I see stuff all the time being called out that may not be compatible with that product that's on the roof, and we got to tie into that,
Yeah.
So it's really important to know what we're dealing with, which is, thorough destructive testing reports.
Yeah, we'll talk about
We'll
material
tell you a lot about
incompatibilities
that.
as well. Yeah, exactly. So these are all things that, as architects, we know that these go on during construction, but they are also provide risk to us, right? If something fails there, then we're going to be heavily scrutinized from our construction documents and specifications. When we talk about new materials, there's things that have a long-term performance record, like your classic building paper, new things that have come on the market in the more recent past, like your self-adhered weather barriers, and now in the more recent past, liquid applieds, right? So these all have sort of benefits and analysis. But when you're speccing materials, you kind of want to think about what is the long-term performance record of the product I'm specifying? What is the general experience with the contractor and the installer with that particular product? And are they going to be successful? Have they done this before? What's the longest service life of a project they've had? Can we go check that out? Things like that.
If you, on this topic, when you're installing foam continuous insulation, do you put the water barrier behind the foam or is it?
I usually put it behind the foam. Depends on your assembly, but typically, if you're talking like a wood stud or metal stud with sheathing and then continuous insulation and then your cladding outboard of that, I put it on the sheathing at the structure, not at the foam.
But doesn't the foam itself block passage of the air?
Are you talking about spray foam?
No, I'm talking about,
Like rigid CI? It can. Generally, you can leave an air gap there too to promote vapor diffusion and airflow. Yeah.
so it just seemed like there were like two planes that would block flow of air, one in the case of the foam, the second one was proper WRB behind.
Yeah, so the WRB can perform as both your water, air, and vapor barrier, depending on the product. In that case, you probably want to have like a spacer or something at your CI, depending on what, there's an analysis called WUFI, which is an anagram for a German word that I can't say very well.
Yeah.
But it analyzes the dew point that would occur for your specific climate zone in a specific assembly. So you can model that and see where your dew points and dryings will occur during that. It's like a single line diagram, basically. So, but in general, your weather.
What would be like your official recommendation as an engineering firm, as a best practice? Say WRB behind
So
the rigid.
typically, it depends on the project first, and then secondly, at the vast majority of the projects, I would have the weather barrier behind the foam on the structural sheathing, or the jib sheathing, or whatever it
Our
is.
consideration as the manufacturer, what substrates we can adhere to. So it's much better adhering to the sheathing as opposed to trying to stick to the foam.
Okay, yeah.
Yeah. Okay, We talked about market conditions. We all kind of had a good chuckle, but these are real. People have, I'm sure right now, people have canceled jobs because of what happened in the market 2 days ago. They don't know. And so these things can affect both material availability and our ability to perform other services that we were counting on, like those CA sort of services. When we talk about additional risks, it's always higher to repair something than it is to construct it again. We selected demolition. Here's a photo of a control joint that was missed in an elevation. We had to go in and chip out very carefully so we don't damage the existing adjacent waterproofing, so we can install the new control joint here. So that sort of intricacy of work is generally leads to higher construction costs, which would be something that would be part of a litigation or an insurance action.
I have a question on that.
Yes.
So was there a crack made along the construction joint that happened?
Yeah, so in this particular case, there was cracking happening along here. The spacing between control joints was too great. Cracking was manifesting elsewhere, so we needed to put a control, it extended beyond the 144
But there
square
wasn't a
foot.
leak going on, there was just a crack going on.
This in particular one was a cracking thing, but, with cracks
The
come.
waterproofing took care of whatever got behind.
In this particular case, that's correct, but I mean, if a crack occurs at a vulnerable spot in your assembly, exactly. I'll talk about that as well in a little bit, about redundancies in design, yes.
Just a point, reconstruction, does that have a specific definition?
Oh, when I say reconstruction, I'm talking about a building that has some sort of failure that now that particular failure needs to be corrected. We talked briefly about relocating occupants if that needs to happen. So that's another additional cost that could be part of a litigation action and a risk to us. So what does a well-developed enclosure strategy look like? Redundancies, like you were just talking about. We want to avoid reliance on a single potential point of failure if we can in our designs. So that means generally providing, at least 2 ways for this thing to fail before water can get to your structure. So when that happens, we can extend the service lives of products and materials beyond their warrantable period. We have less disruptive replacement costs, and we can reduce mechanical loads from air leakage. All of these things kind of are part of a well-developed enclosure strategy. And that also helps ensure our long-term structural performance. So let's talk about redundancy. Generally, we want to direct water away from wherever it can get in, right? So we want to reduce the reliance on an installer. People build buildings. People make errors. So we want to try to reduce the amount of, or increase the number of errors that have to happen before we get to a leak, if that makes sense. So one very simple thing is head flashings. A lot of window manufacturers in their standard details, they don't even mention head flashings. But we want to get water away from that window before it can even get a chance to touch that window. Similarly, roof penetrations, storm collars before we even get to the roofing termination. These are things that keep water off there before we have to rely on the very last sort of line of defense. When we talk about extending service lives, we want to extend the service life not only of our waterproofing materials, but the substrates and the structures they protect. So that means keeping water off this thing as long as we can to have your building have a very long lifespan and not have to be torn down or replaced within 10, 15, 20, 30 years, right? We want the 50, 100-year buildings. But this requires a lot. We got to coordinate with building owners and the operational staff to be sure proper maintenance schedules are performed, things like that. One very simple one that we talked about previously is the new code requirement for this drainage plan. There's a drainage matrix outboard of the building paper right here. That, number one, it just keeps water. Cement plaster will soak up water and that will want to sit against your waterproofing. A drainage plane just gravity will break the capillary action and will just travel down. We get water off there. So that's a really easy way, that's now code required for new construction, but a really easy way to just keep water off and extend the life of your cladding and your structure. Less disruptive replacement costs. So when we design things, we want to kind of limit A really classic example I see of a placement that doesn't consider this is a re-roof with a upturn on a stucco wall, and you see the sheet metal on the face of the stucco, right? You see that everywhere in a bunch of homes around. That is really not good practice, because now we have a breach in the waterproofing levels between the WRB and the roof. So we want to consider that when we're designing systems, so when we have to replace a roof, we can design things like reglets and counterflashings to be able to pull those off and replace sheet metal rather than chip stucco at the base of a wall. When we talk about reduction in mechanical loads, we want to ensure that, first we want to reduce air leakage, and we want to reduce the introduction of additional humidity sources. Just water in your buildings will create additional humidity, so then your mechanical equipment has to work harder to dehumidify and condition the air. And these are things like blower doors that we use to test these sort of things during the construction process. So that's another way to just kind of keep your building operational, so that initial investment for your owner extends for the longest time possible, right? Oops, going the wrong way. Long-term structural performance. This is probably the biggest one, right? We want to protect our structural system from any decay and corrosion. Here's a photo of a building that has obvious something's going on. There's some sort of vapor transmission. You can see it telegraphing through the studs. When you open it up, lo and behold, sheathing's pretty much toasted. The studs are on their way, right? This is a complete rebuild. That was a really recently built building as well, right? So these things can happen fast, especially in our new construction methodologies where we are required by the energy code to provide less air exchanges per hour.
Do you think that happened from the inside or from the outside?
And what was the system that was there? Is that like OSB with building paper on it?
You know, I didn't work on this building, but I'm not sure, Megan, if you or Kristen, it looks like we have OSB on the exterior sheathing with the back of the gyp that we can see is the white, right? The interior gyp.
I believe I was 7 years old when we figured out, and we opened up that picture right there.
7 years old, is that
You
one?
should see it, it looks like the internal is on fire.
That's crazy.
It's oil with nature.
Is that here in Berkeley?
That was actually over in North Bay.
Right next to your house, I think.
So the question was, do you think it was from the inside or the outside?
It could have been, it's probably a couple different sources. So you can have cracking and leaking in the building, in the stucco specifically, where it can absorb water. And if you have a temperature differential, your vapor drive is going to go one way or the other, right? So you can have condensation happening on the back of OSB sheathing at the same time having water sitting on the front of it. I don't know the specific of this particular project, but if I were to guess, it's probably a combination of things. Interestingly, with forensics or things like this, there are lots of different ways. So you kind of have to use the scientific method, right? We got to rule out some things to see what is actually the problem, right? A lot of testing happens there. We'll talk about some more testing later. Yes.
So another thing to keep in mind in multifamily and like hotels and stuff like that is you've got a ton of individual rooms with people showering, people cooking. You're generating a ton of humidity inside that building as well.
Especially when you look at the way that is shadowing all of that.
Yes.
And it's so consistent. It's not under a particular window.
Correct.
I also think that I don't see any blue.
Yeah, this to me looks like an interior vapor drive issue that I couldn't breathe.
Yeah, I don't know. Sort of get that feeling.
Yeah. So common issues of poor enclosure design, lack of redundancy like we had talked about, lack of continuity and poor transitioning. This is kind of where we have a really good idea of what a detail is going to be in the field, right? What happens when it hits a sidewall? What happens when it hits something else in transitions? Those are usually where we can get into trouble as architects.
On the topic of continuity,
Yes.
is it a good idea or is it a mistake if you have the drainage in a rain screen system, if you have the drainage plane running straight down into the foundation?
Oh, I see. Like, so if it drips water right down there?
Yeah, like that dimple near a drain, whatever it's called.
Mhm.
Like instead of that sheet metal flashing, like dumping the water outside the building, it just drains right into the foundation capillary break.
So, I mean, in general, we prefer to get water and kick it away from foundation walls.
Okay.
So if you're talking about a weather barrier with a drainage plane, you're probably gonna have two pieces of sheet metal at the base of the wall right there. One as your stucco accessory, and one as your kick flashing at the base of the drainage plane.
Okay, but there would be, it sounds like you said it would not be a good idea to have one continuous drainage plane that runs from the top of the building down to the foundation.
Oh, are you talking about like in a backfill where you have waterproofing on a concrete below grade wall or something like that?
Yeah.
In that case, I would need to think about it, but I don't necessarily see a problem. In general, however, when we have an opportunity to kick water away, I like to do that. Because now your below grade system is taking not only everything in the soil, it's taking everything in your wall too.
I would kick it out and away. And the other thing is when we kick things out and away like that, we also open up airflow at the base of the wall.
Correct, yeah, so you get that drying.
So
Yeah,
you
exactly.
need that. And I don't know how you would do that because typically we terminate below grade drainage boards with some sort of termination bar.
Yeah, exactly.
We want to terminate it into the assembly, so.
I think it would just be if it's,
Terminate the pin and then flash over the top.
yeah, usually you're gonna have some sort of soil right there, right, where you wanna hide something.
Yeah.
So that's your spot to kick and then terminate from below, yeah.
Okay.
We talked about this before, a misunderstanding of appropriate material applications. That happens often, not just for architects, but for contractors as well, about what materials belong where. So these are issues that we run into as architects, that we need to be sure we're specifying the correct products in the right application. This is a classic example where you have a bituminous material with some sort of PVC or something like that. I don't know, there's two material incompatibilities here, and that drip, that black drip, is melting out waterproofing basically. It's no longer doing its job.
It's probably that bituthane over some kind of vinyl that really doesn't like to be
Correct,
in
yeah.
contact with each other.
Generally, yeah. And increased condensation potential. This is a photo of a window, a single pane window, but condensation can also happen within building assemblies. We'll talk about that in a sec too. This is a really more visual. So let's talk about lack of redundancy. When we design, we want to reduce the reliance on the performance of a single component. If we're relying on a single sealant joint for something to perform for a long time, and a human person is installing that thing, we have a very good chance that somewhere along the line, we're gonna have a breach, right? So the more layers we can get in front of that thing that we want to protect, the better and longer our buildings are gonna perform. So right here we have a typical, this is kind of going towards enhancing manufacturer details. We have a window manufacturer detail that just calls for a single line of sealant at their windows. That was what it was installed here, right? And we had a breach. Something we'd like to do more generally is take our rough opening flashings all the way in, provide an interior sealant bead as well, so we can provide continuity at the back of the window in case there's a leak of the product, let's say, it doesn't go all the way into the building, you can get out of that rough opening right there. This requires coordination with your sill detail conditions as well, right? Because if water does get in there, we need to provide a way for it to leap out.
So I can't see it well enough, but is there a way for it to get out if it gets in?
Yeah, well, this is just a jam condition. At the sill, we would have either some weep tubes or gaps in the sealant to the front, so we can let water out in case it does come in.
This will also help to minimize air leakage out of your rough opening.
Correct, yeah, so the interior bead here where it says new seal, I don't have my pointer doesn't work, but if you see right here, we're talking about that bead right here, additional waterproofing protection, and it helps control airflow, or air control. So that also means you don't have to use your mechanical equipment as much because you're going to be able to rely on less air exchanges through the whole assembly.
So that's a backer rod you just pointed out too?
Backer rod and sealant, yeah.
And the sealant on top.
Correct, yes.
Basically back and shoot both sides of the window to the rough opening,
Yeah.
but you don't.
To the rough opening flashing, not just, so that's one thing you want to do too, is extend your rough opening flashings all the way into your rough openings so you can seal directly to that, between the window frame and the flashing member, not the framing member. We can talk more specifically about later if you have any questions on how to do those details or perform those details or draw those details. It's totally, we can definitely do that. When we talk about lacking continuity in installation and in design sometimes, this is a project where we have a membrane on top of a parapet wall and it's not lapping on to the house wrap there, right? That's a discontinuity. clear as day. Not, this is a really good example of something in the field, but we also do that sometimes in our drawings where we have different conditions where we have, let's say, a roof to wall or something like that, where we don't turn an underlayment up to interface with the air and water barrier behind that, so we can end up with gaps in waterproofing that we want to avoid. And transition detailing, this is another good example. This is a reverse lap. So we have our white house wrap in the back with our foil faced flashing, which is on top of that. You want to have when you use sheet goods, you want to have it shingled down so water will exit. If water comes from the top of the white and heads down, it's going to work on that leading edge of the flashing member right there, the self-adhered, and try to get behind there and start working on getting to the structure below.
Is that a parapet?
This is at a roof to wall. And another thing they did here is they didn't terminate the roof very well, and that kind of crumply, that's just mastic that they stuck up against there and then granulated it so it looks like a roof, but really it's not.
So they should have taken the white stuff and have it overlap before the flash?
Correct. So first, the roof should turn up behind everything.
But that would have to be done before the building paper is all on.
Correct,
Sort of
yes.
a backwards kind of sequence maybe in some cases.
Potentially. So those are things we can control in our detailing, and then hopefully we can clarify during construction administration with contractors, right? If we show it how we want it to be built, they'll be required to do that per the contract, right? So that, even though we're not.
Roofing done before all the building wrap goes on.
Sometimes, yeah. So it does get into a means and methods question, right? But if we show the intent there, we need that roof there first.
If you're gonna do it from a sequencing standpoint, though, you can run your building wrap down and then leave the bottom end and flat. Run your roofing, and come back down and tie the two together.
And we talked briefly about material appropriateness, Is the substrate suitable? Are we specifying things that are meant to go on the things that we want them to go on? For example, we have a waterproofing membrane that's turned up onto a piece of a face gypsum product, right? That's not necessarily the right application for that. That facer wants to pull off. That should probably be a more integrated roof cover board right there, where you can expect more pushing and pulling of that membrane on that facer. Chemical compatibilities, we talked briefly about that before. Aside from just your classic asphaltic and PVCs, there are also things like, pressure treated wood and lumber applications next to cementitious materials, right? We want to be sure that those happen. And the physical properties of the material that's going on here. This is another example of that same parapet wall. They just wrapped the house wrap over the top of this to put it below a coping cap, a metal coping cap. That is not what that was intended for, right? So we need to think about those things when we're drawing too. We need to specify our high temp membranes under our metal coping caps and be sure that we kind of have that appropriateness of materials that we want to have happen within our assemblies.
So what would you do there? They're going to put a coping cap over that.
Correct.
Right? But how would you do it differently?
I would end the Tyvek on the vertical, and then I would put a high temp membrane over the top of that as
something thicker and more substantial.
And it has self-healing qualities as well. And generally, you'd want to fasten your cleat on the vertical side so you can.
So it's straight.
So you don't have any penetrations on the top horizontal right there. Yeah, exactly.
The high temp is key because that sheet metal is going to be
It
cooking.
gets hot. And
It
kills
gets hot.
Everything underneath it. Yeah.
Very, very hot. Increased condensation potential. This is something that we don't really know a lot about as architects in general, right? So when we talk about condensation, we can see a single pane window clear as day. But when we think about other assemblies, where is the dew point in this assembly, right? So this is a single ply roof that was applied in a residential situation. We look at the interior, the attic space here, not a lot going on, not a lot of insulation. So there's the heat transfer and the temperature differential between the interior conditioned space and the exterior hot or cold can be quite drastic, right? And we end up with things like staining and water condensating on the top of ceilings right here, right? So we need to understand how this assembly works together, right? It's not just a roof, it's all the things below the roof, including the cover board, the insulation, all these things work in unison to provide a good enclosure design.
So what happened there is that the roof during the early morning got like really, really cold warm attic air that had a lot of moisture in it, hits it, and then it condenses.
That's exactly right. And it can, different times of year, in our climate area, it can go both ways, right? You can be cooling inside and it can be very hot on the outside too, right?
But you don't care about condensation on the outside, do you?
Not particularly, but I mean, that condensation happens, right? As when we talk about, so in other climate areas, they have vapor control areas on different parts of the building, as we do here in the Bay. But we just need to consider where we want to put all those sort of control layers, right? Poor enclosure design can lead to stuff like water intrusion, like we know, DKF members, biogrowth and mold, poor indoor air quality. These are things we found in a single assembly here. This is a wall with the vapor barrier on the interior. You open that up, you can see that the OSB sheathing is not in great shape. You have mold happening right here, and we've got a, you know, for all intents and purposes, this is a fully saturated piece of wood right here. So these are the things we want to consider. You know, this vapor barrier being right there, was that the right choice here? I'm not sure. But now we got to go look at our architect's drawings to see what was going on
So
there.
did it happen from the inside or the outside, do you think, on this one?
This one, I'm not quite sure. I didn't work on this one either.
If you were to guess.
But I mean, we have standing on the interior side, you know, there's,
The one that the drawings don't fail, it's against our.
oh, yeah, exactly. So how do we mitigate these risks? There's lots of different ways, a few different things we can do as architects to mitigate our risks with our drawings and specifications. Building envelope consultants help. They can provide these sort of things that we're going to talk about as well. Peer review, specification-driven requirements, testing. Testing is great. If you can get testing on your job, do it. And of course, CA involvement, construction administration. So what are the things that we want to look for from a peer review? Or what are the things that they help accomplish? Recommending different materials and systems that are appropriate for the application. One thing that we talk about is like providing a matrix of different conditions within your building and appropriate products for those particular conditions. Reviewing drawings. You know, have your drawings checked out by another professional. When we're in our drawings, we often have a hard time kind of pulling out and seeing the big picture, right? And we have set of fresh eyes to look at it. They can catch things that we don't necessarily see while we're working on them. For example, like in this particular drawing, there was no waterproofing was called out below the mat slab. That's something we can easily miss as an architect, right? But not something that, you know, if you're having a peer review, that gets missed very often. Though, including things like details, you know, enhancing and providing that redundancy. And reviewing specs, you know, considering our typical specifications that we issue, and then we can say, oh, hey, we forgot about this thing, you forgot about this material, what about over here, right? We didn't call that out. So these are things that we can kind of catch in peer review to help get our construction documents a lot tighter before we publish. When we talk about specs are a great way to help control the construction process on the project, right? A 3-part specification is really, really good because you're going to have things in there. 1.2, you see it right there. There's a ton of ASTM relationship or standards in here that will be part of this spec. So now you have some actual testing and testing requirements for things that go on your building, right? Not just, hey, I found this thing on the street, let's do it. And for what sort of submittals that you want to see as an architect. When do I get those into you? Product data, samples, etc. Beyond just kind of, well, we can talk about warranties and stuff too, but mock-ups are great. If you can do something like, you know, constructing mock-ups of assemblies or particular products, that is great, so you can see how it can perform in real life before it is, you know, in your building 100%. Testing, like I had mentioned, testing is awesome. If you can do it, please do. Things that are really easy to do, first test of a window install. Do that every time. It doesn't take a lot of coordination with the contractor, and it tells you a lot about that installation.
And you're talking about spraying water all over everything, right?
Correct.
For how long do you do that?
It depends on the methodology. So there's a few different, we can talk about that in a sec, but there's a few different ways to do that, yeah. And when I talk about testing requirements, these are things like, for this specific, this is for sealants, 079,000, I think, is the spec section. But this describes the testing that we want to do. So all these things are documented within your construction documents that are then the basis of the contract, which the contractor is now required to perform. So those are all things that we can insert into our construction documents as architects to help ensure the success of the building and mitigate our risk in terms of, exposures there. And warranty requirements. Sometimes manufacturers will offer a warranty, but oftentimes we also want workmanship warranty. So it's important to specify both of those on here. And that the warranties that we're specifying are appropriate for the application right here, right? Jamie will tell you that he's not going to issue a no dollar limit warranty on an elevator pit, right? Things like that. So we just want to work, probably talk with your manufacturer rep to see what warranties are appropriate. And execution requirements. These are part of the three-part spec right here too. So making sure that we kind of more spell out the way that we want substrates prepared, the way that we want to have all these things executed. Quality assurance, when we talk about mock-ups, functional mock-ups are great. Depending on the scale, this can be on the first install on your building, or it can be a standalone before it gets kind of moved out of the contractor's yard and they've fully mobilized, right? But having to see these things in different stages, so we have a scratch code of stucco right here with a, you can see the transitions happening or how it's going to be constructed. This is how it's going to be. So we do it once as a test, as a view, not just sort of how everything looks or the thicknesses of things, but also the steps involved in the flashing and how it can perform.
Do you ever do the water test with a negative pressure on the inside?
Yes, that's the ASTM E1105. We do that quite often.
Have
Yes.
you seen stuff leak?
Yes, quite often.
And where does it usually leak?
Where does it usually leak? Well, different people will tell you the same thing. The window manufacturers will always tell you it's the sealant joint that leaks,
Okay.
right?
But since you're agnostic, what do you believe?
I generally find that the window products perform okay as long as you don't, every window will have its own performance grade, and so you test to that grade, right? And that's in the field testing, you reduce that pressure by 2/3 or by 1/3 or whatever, I forget. But in the field testing, so you just have to make sure you're pulling the right amount of air on that thing. A lot of times, and then there's a few different things that happen there. There's different trades happen, right? Your framer and your waterproofer will do the rough openings probably, most likely, right? And then your window installer will come in and do the sealant bead right there. So oftentimes, like I mentioned before, it's not necessarily the field condition that's there, it's where things transition. And that's a lot of times the case with window installs too, where you have one trade transitioning to another. Somebody misses something. So a lot of times that's where I see it's not necessarily the window, but it's the entire installation as a whole component. Assembly,
So
excuse me.
what will you see as the reason for the failure? Just the sealant?
It can depend. I mean, sometimes there's reverse laps that things get pulled into. Sometimes there's not a sufficient back dam of a sill pan. There's a breach in the sealant. There's, something's applied too thin. A membrane isn't rolled correctly. There's lots of different ways for it to fail. Yeah.
Did a project that we were on not too long ago, and 3 different trades touching the air and vapor barrier. All 3 trades provided submittals for our system. All 3 submittals were approved by the architect, and they submitted different products for the same applications. Some guys had the louver assemblies, and submitted certain products for that were approved. Other guys had the window assemblies, and then there were storefront windows versus nail pen, all different. When we went out there for the mock-ups, it was a mess because the general contractor broke that scope up. So of course, that thing was a nightmare waiting to happen. Fortunately, we headed it off. But it's not necessarily that a product or anything failed, the system fails in that case.
And so what would you have done differently in this particular?
Put it all under one trade, so
Under
one
trade.
contractor.
Under one contractor, right?
Yes, absolutely.
And as architects, that's part of the specifications there too, right? Those are things we can mandate as the product for those specific things, and help control that from a contractual standpoint. like you just mentioned, here's an example of a window water test, right? This is the ASTM E1105. This is in a diagnostic situation, but usually if you want to test this thing, you would put a chamber on the inside and you have the same sort of spray rack. It has a certain amount of water per gallon flow per minute, and you put a certain pressure on it, and then you pull air and see, because it wants to replicate a wind-driven rain event, basically, for the performance grid that the windows are specified for. Other testing is your nozzle test. I think this is the AMA 501.2, I think. This is mostly a diagnostic tool. Sometimes you can use it in like curtain wall assemblies at the base of wall, stuff like that for new construction. It's where you kind of just, I think you move 5 feet per 5 minutes or something like that. So it's kind of slow going, but it shoots a lot of pressure pretty quickly right there. These are, of course, it's a lot easier on our side if we can get this on the performance end before, before the building's, commissioned and signed off on, rather than as a diagnostic tool to figure out why it's leaking, right? Flood tests, I'm sure you guys have done before, right? You have a membrane on a deck somewhere, you let water hang there for 24 hours and see what you lost. CA, one of the things we can do here is review installed work. This is Kristen's finger right here, looking at a not so great sealant joint that wasn't tooled properly, or maybe the substrate wasn't prepared properly. We're not sure yet. Things like you can barely see right here, but this level is bending back towards the building, right? So these are things we can kind of catch in CA that we can, like you had said, recommend to the owner they reject. This you can't quite make out, but there's really shoddy mortar work at the top on this ridge right here. And that is just not a workmanship quality. It's probably not compacted very well. You may lead to issues right there with absorption and water getting behind your roof at the very top, right?
Maybe they intended it to be a ridge vent.
Maybe, yeah. Another thing that we can do is provide for a submittal review, and these are things like, Chad, you were just talking about submittal review. When we have a project, we issue our specifications, and then we have all these things that we want to see, your product data, safety data, not just the single product that we're specifying as a broad term, but the whole assembly, right? All of these products have accessories, right? So we want to see all that data before they go onto the building. Sometimes there's a substitution request. Sometimes it's good. Hey, we have this product that we see on here as our basis of design. We can save you some headaches with a different type of weather barrier, right? Drainable. Great, let's do it. Same cost though, right? And then of course, when you stamp off and sign on those things, we can say exceptions taken, rejected, what have you. That's the sort of power you have as an architect to make sure it's in conformance with the project documents. RFIs, I'm on a job recently where the architect did not get an RFI on a 5-story remodel in Pack Heights for the whole project. And it's a mess. So when you do that,
Why didn't he get one?
that was just
Whose fault was that?
well, I mean, I would generally say it's the contractors by not involving the architect right here. But that leads, so when we see a failure right there, now everything gets scrutinized, right? Every single detail, every single condition, every single assembly. So that's why we need to make sure that our drawing packages are as tight as they possibly can, so we avoid those sort of leaving things up to other people to interpret without us being there as it's being constructed. But then also we need to make sure to protect ourselves as professionals on the front ends for any sort of litigation action that we could see because of someone else there.
Not many 5-story houses in Pacific Heights.
It's a 4+ basement, yeah.
Really? What street?
I don't think I can
Pacific
say.
Avenue, probably.
Close.
Yeah.
So these are things like, hey, we encountered, this is a great example of an RFI. We're asked to do something, we found water, how do you want us to fix it? Perfect, do this, please. That's the kind of how you want it to happen from an RFI standpoint. Something is unknown or unexpected, how do we deal with it to be in conformance with the general intent of the design? So this is an interesting thing here. So we have a detail, right? This is a wall at slab, It was installed pretty close to what was detailed. We see elevated moisture towards the base of the wall. That's the OSB sheathing right there. You see the 23.5, that's moisture content. 13.9, that's relatively dry. 15.1, relatively dry. 23.5, you're starting to get elevated. That would be considered wet. And lo and behold, we have a failure here on the slab, right? So who would be responsible for this failure? Well, we're not sure yet, right? But there's a few things that I didn't tell you about this thing, right? So this detail occurs on the second level of a 4-level building, right? So we have, above that is continuous stucco for 2 more levels. So as water travels down the stucco assembly, it doesn't have a place to kick out as it loads up that wall where it hits that slab.
The slab is on what level?
Level 2. It's kind of like a podium construction.
So moisture was soaking the stucco assembly and it was going through
Creeping into the slab.
transition?
Correct. So moisture was loading up the wall, 2 stories of stucco on top of this detail, basically, right? Coming down and finding a weak point in that assembly, right? And it's usually going to be because of unadhering of the, depends on what's happening there. But from a design standpoint, we want to kick water off there if we can right here, right? So in this particular condition, you want to provide a wall flashing here to kick water out of your assembly before it even has a chance.
So you're saying you'd have to drain it before it gets to the concrete?
Yes.
Correct. Yeah. In general, for stucco systems, I would highly recommend that if you have 2 stories of stucco,
Terminated above.
you need to at least kick out every 2 stories. If you can kick out every single story, that would be better. Depending on I know that sometimes.
But then how would you avoid having that ugly metal flashing all the way?
That's your cost benefit right there, man.
You have to have a competent designer
Yes,
to help hide it.
we can do that too. Yeah.
But the concrete did not rot out there, did it?
The concrete was it was fine, but
The wood didn't rot out either.
not yet. But
It will.
it will.
Yeah.
Yeah. So in summation, design and construction is challenging. There's a lot of different things we have to deal with as architects, not only from waterproofing, but just in general, codes are becoming more restrictive. I'm sure that you've seen after our recent wildfire events, we need to be more aware of our wildlife-urban interface zones too, right? So we have a lot of things to consider when we're designing a building, not just water.
Do you guys ever use AI to read code before you design?
I haven't yet. I don't think I want to. I might have it locate a passage for me, but I want to interpret that myself, I think. Yeah.
Now that you brought up fire.
Oh, yeah.
Are we concerned with a drainage point now with fire?
I'm not quite sure. We will need to do some more testing on that.
Well, there are intermessid strips that you can use to create your airspace that will also expand and stop any growth of smoke in the pipe in a cavity.
Yeah.
The question is, when is it appropriate to use those and how many and all that? There's a certain amount of detail.
And then if there was an event that would need to get torn out in order to, because it's sealing off, isn't it?
It depends on how they're executed.
Yeah, so there's a lot of things to consider as an architect, right? And it's really challenging. Jamie, you have a question?
When I first moved up here, back to Northern California, we had like 6 new construction, full buildings that were ready for like cladding, completely burned to the ground. The one in Mission, I think it was like Mission Bay, was like, I think the first one, but NFPA 285 kind of came out of that, right? So it's, any building that's over 40 feet or 4 stories has to be tested in an NFPA 285, wall assembly. The WUI challenges. I mean, there's a lot of stuff that's coming out now. I have a job over in Atherton that they're putting a product on the wall. I see it everywhere in Tahoe, and it's the worst substrate ever. It just falls apart. It's like particle board. I don't want to pick on anybody, but
No, go ahead.
flame block.
Okay, don't know.
We can't put LP flame block. We can't put a fluid applied air barrier on it. It's just the stuff UV degrades it. We're seeing a lot. PyroGuard's another one. We're seeing Advantech sheathing. I mean, we're just seeing a lot more products now that are being introduced.
Yeah.
How about that blue skin
Can
stuff?
I ask you, because you seem, it's a bit of a segue, but it seems like a rare opportunity.
Sure.
Do you use that, I should probably do it, sorry.
The microphone.
I know
Do you use, or have you seen used, that magnesium oxide cement board instead of OSB? And do you like or dislike it?
I'm not really sure. I mean, like cement boards are great in general. I'm not sure about the magnesium oxide, but, like dense glass too. You saw the face that was pulled off on that photo. A lot of people think dense glass is a great substrate for fully bonded waterproofing.
It's not
We
very
won't warranty going over that. On an upturn, in certain conditions, we might, not on a horizontal surface, we won't warranty going over OSB. It's so water like a sponge and the blues in there, start to expand.
Shouldn't the code just prohibit OSB for sheathing?
I think so.
Yeah, me too.
Well, Jamie's talking about on a horizontal substrate versus a vertical, like vertical, if you're doing a fluid applied or peel and stick, OSB is okay, it's just,
Yeah, and
it's
that's the
not great.
application I was thinking, like using magnesium oxide cement board instead of OSB on roof sheathing. Like, do you?
Christy might have something to say.
No, I have actually no comment. I would just recommend something like that.
Yeah, I mean,
Let's do some very thorough product research and testing.
it seems like a miracle material, but I keep hearing this from people in the field. I can't make it make sense in my mind.
Most of the architects can be attracted to things that seem better than sliced bread often. And generally those result in large scale failures. So, there's another example of cell-free per roof, lightweight expanded concrete on a roof to provide a slope.
Yeah,
There's
people
just-
put waterproofing over the top of that before it's fully cured and it's just wet and it just doesn't bond, you get a problem.
There's a lot of like snake oil type of stuff in this industry. And you look at some of the buildings in the city that they were told that you could put all your waterproofing in your admixture in concrete, positive side waterproofing when you're 5 stories into the water table.
That works.
Holding back brackets for the water.
Well, it works for us
Was that
because
the
we sell.
Is that the
So-
Zypex stuff, or is it?
That's
something-
one of them.
Amongst other, yeah. Yeah, so that kind of goes back to what I was talking about is the products that are out there. Do they have, when we specify as architects, does this thing have a track record of success, right? If not, we may want to reconsider.
But some of that stuff was a reaction to COVID. I had clients telling me,
Oh, yeah.
I can't get plywood, so use this other shit so that I can get my buildings done on schedule.
Absolutely.
Use, the magnesium oxide cement.
So, no, I haven't gone down that road, but some of the other products we were just talking about in terms of alternates to plywood sheathing, yeah, they were like, we can't pull regular plywood, so
Yeah,
use this because someone else down the street used it and they can get it tomorrow.
yeah, we saw that as well. One thing that was good about that is manufacturers also saw that. So then when there were material sort of shortages like that and availability issues, manufacturers generally stepped up to the plate to provide a warranty on those sort of non-standard things. So that's something you want to work with, whatever you're putting on your building to be sure that even though there is a material shortage, let's say, can it still be warranted and will you provide an exception in this particular case? So yeah, like we're all just talking about, there's a lot of things that can go wrong, right? So what sort of risks do we have and how can we mitigate them? And so we can identify risks in very different ways and we can reduce them in really different strategies because we don't want to end up where our detail gets installed correctly, but it's just not right. And in this particular detail, you can see there's a dimension between a weed screen and the top of a tile, 1/8 of an inch, much too little to avoid a capillary action back towards the base of wall right there. So that's it from us. And if you guys have any other questions, I'm happy to see them. Oh yeah, and if you have your, this little QR code right here is if you have any feedback on the presentation, I'd love to get that. You can also give us any other questions.
What's your favorite wall construction for? Give me the details, starting from the inside all the way.
Well, I don't know if I can do that very well right now. Honestly, it depends. It depends on what you want to go for and
A house. A house
for a house in what climate.
in Berkeley.
Yeah,
question.
yeah, I don't know, man. If I
I'm not
saw,
gonna hold you to it.
if I
Just
saw
give me-
a section cut of it, I would, so generally this, okay, right.
let's
Is
start
it a
from the
new
inside.
construction or a reconstruction?
New construction.
Hypothetically speaking.
This is a hypothetical new construction.
This is
Yeah,
off the record.
exactly. So you'd have your interior gyp, you would have your studs and your insulation, your,
What installation would you have?
well, okay, so generally, this is all subject to,
I know.
this is, again, this is not, but I would want something that doesn't necessarily, isn't necessarily conducive to any biogrowth.
Okay, so you don't want old blue jean material.
Nope, and I don't want pink cotton candy.
Would you
I want-
use,
Not necessarily spray foam either.
Would you use?
Sometimes it doesn't breathe the way I want
Rock
it to.
wool or something.
You like rock wool, right?
Typically, yeah.
Cement foam.
I don't, so spray foams can get tricky because there's open cells and closed cells. And so it, depending on the way you want your wall to breathe, you know, that can have a really big effect on that, right? And that can lead to condensation issues that you don't necessarily see right away, but when you do, they're catastrophic failures. So generally, personally, I like things to breathe, right? And so that's vapor open.
All the way through. So that would be sheet rock, studs, rock wool, maybe,
Sheet rock,
then plywood as the sheathing.
Correct.
And then another waterproof membrane.
Then on your structural sheathing, I would, and depending on if you have a 1 hour wall, you'd have your Type X chip out there, but if it's just a
Regular wall, let's just say.
I would have either a liquid or a vapor apply, or a liquid or a self-adhered sheet, waterproofing membrane, or a weather barrier right there, vapor open most likely, and then your cladding on top.
Do you like Vapor Shield? Do you know them?
Yeah.
They're good, huh?
Yeah.
And then you would have furring strips?
Yeah, depending on what your cladding is, yeah, you could have furring
Regardless
strips.
of the cladding, you're gonna have, you want an air space there.
Well, if you have stucco, you can probably apply your air gap, just fasten through, most likely.
Meaning that you're attaching the lath directly to the waterproof membrane?
No, you'd have to apply the lath at the studs. You have to make sure you don't miss.
Okay, I won't make you go any further.
Thank you. If you have a specific question, I'm happy to look at your drawing for you.
You just asked Sydney and there's no questions on mine for
Okay, great.
20 under 1.
Anything else, guys?
Thank you, Matt.
Appreciate your time. Thank you.